name is Nindhia, and in today's video, I'm going to be talking about a Vickers test that I performed on a vespa piston as well as a supra boring or supra cylinder. So the Vickers test is a hardness test used to measure a material's resistance to permanent deformation, specifically indentation. It's widely used because it works for almost all materials, soft to very hard. This test evaluates material uniformity, detects phases differences, assess case hardening depth, and observe the effects of manufacturing processes. The Vickers indenter is a diamond pyramid with a square base and an angle of 136 degrees between opposite faces. In this experiment, the applied load was about 0.8 kg or 0.8 kg force. A piston and oil dashpot are used to control both the loading rate and the dwell time is around 10 seconds. So now moving on to measurement. After removing the load, the indentation left on the specimen is measured using a microscope. The two diagonal lengths are measured to get the average. So to get the average, you addition D1 and D2, so the first diameter and second diameter. Then the average diagonal D is calculated from those two values. So we divide it by 2. Next, we put the applied test force F in kilograms force or kgf and the average diagonal length D in milliliters into the formula, where Hg is the hardness of Vickers hardness, the 1.8544 is the constant, F is the load in kgf. In this experiment, it is 0.8, and then the D2, it varies because I made 3 indentation. The result is technically in kgf per millimeter power of 2, but usually reported as a dimensionless hardness value. So now this is the material preparation that we did. The piston pieces were cut into small strips, as you can see in figure A and B. The samples were then embedded in resin and polished, first with sandpaper, then using a velvet cloth and alcohol. There are 2 sample types, vespa piston on the left and a supra cylinder boring on the right. Each one of the embedded resin is about 2 centimeters in total diameter. Now the test parameters. The applied load is 0.8 kg or 0.8 kg force. The dwell time is about 10 seconds. The sample tested were vespa piston with 3 indentations. Each sample has 3 indentations, so the vespa piston and supra boring or supra cylinder also has 3 indentations. The software used, Image J, to measure indentation length from micro images, and Future Window, which is the microscope imaging. So using Image J, we are first going to make sure that each pixel represents the actual length in the embedded resin. So calibration done through Analyze and then set scale using known crystal distance. In this case, 0.01 millimeters. For each indentation, we use a straight line tool to measure both diagonals and then press Ctrl M to record the measurement. We repeat this for 3 indentation per sample, then compute the mean. So this is the first indentation on the vespa. The measured diagonal length ranged around 0.156 to 0.18 millimeters. Each indentation's diagonal values were averaged, and the final mean diagonal values for the 3 indentations were recorded and later used for hardness calculation. So this is the results of all 3 indentations. We addition each segment, then divide by 2, and that is how we get the average diameter per indentation. Now, this is the vespa piston. It is all recorded through 40 times magnification under the microscope. A is indentation number 1, B indentation number 2, and 3 indentation number 3 on the vespa piston. So, all 3 online calculators were used to cross-verify results. Gordon England, Omni Calculator, and Tool on Calculator. Each indentation was calculated separately, and all three Vickers values were averaged and compared among tools. Okay, so this is the Vickers hardness number and result for the first indentation using Gordon England. This is for the second indentation, which has the mean diagonal of 0.18. And this is the third one, still from Gordon England. Moving on, we tried Omni Calculator. The only difference here is that it tells the surface area hardness and the tensile strength, but the number still remains the same. The Vickers number still remains the same. For the first one, it is 53.19. The second is 45.79. And then so 60.96 or 61. Next, we also use Toolnet. So this is the mean Vickers test of all the indentation with the average totaling 52.68 or 52.70. Using Toolnet, we also get the same 52.17. This one is just different because it shows the average hardness range, and the average diagonal. Now this is also for the Omni Calculator, also showing 52.70 when you round it up. This shows the surface hardness and the tensile strength. Now moving on to Vickers test on a supra boring or supra cylinder. So we did all the steps that we did for these vespa piston. We first analyzed to make sure that each pixels within the picture is the same length in real life. So the mean diagonal length measured for the supra sample was 0.108 millimeters. The calculations were again valid using the same three online tools. Gordon England, the kilogram force is the same as the vespa, 0.8, with a mean diagonal length of 0.108 and the HV of 127.18. Omni Calculator also shows the same, 127 of HV. And lastly, Omni Calculator, Toolnet Calculator also shows the same of 127. The final mean hardness values of three indentations were calculated for each sample. Results from multiple calculators were compared to ensure consistency and remove calculation error. The Vickers hardness test allows us to compare the mechanical hardness differences between the vespa piston and supra-cylinder materials. These hardness values help assess wear resistance and manufacturing quality of engine components. That is all that I have to offer in this video, and I deeply apologize if I made any mistakes. Thank you so much for watching. Until I see you next time. Bye!